Okay, we're going to use graph and network theory and apply an algorithm to it. Now, an algorithm is a sequence of steps that are repeated again and again in order to achieve a desired outcome. They're great for computer programming because that's all a computer can do. It can do the same thing again and again. So again, look, it's just a repeated set of steps. It's going to be very easy. But before we deal with it, we need to recap what paths and cycles are. So remember, a path is a route through a graph. So a sequence of connected vertices in a graph. Whereas a cycle is a loop. Starts and ends at the same point. Something like that. Okay, a tree. Remember that a tree is a representation where all the nodes are connected, but there are no cycles or no loops in it. So a connected graph with no cycles. Okay, the next definition we need for this is a minimum spanning tree, and it's a tree such that the total length of its edges is as small as possible. In other words, it's a tree like we have on the right hand side, but it's a specific tree that has the minimum number of weights on all of those edges. All right, now we have 4 algorithms in the applied maths course. We're just going to be dealing with the first one, Prim's algorithm, but we'll deal with the other 3 later on and next year. All right, take a look at the next slide. I'd like you to take a note of the time on the video, because you'll probably have to pause it at this time to read through how to do Prim's algorithm if you get stuck. For me, it's much simpler than that because it is an algorithm. It's a repeated set of steps. And I'll give you an example, and you'll see that those steps are always going to be the same.